We recall from our video on circles in algebra that the circle with a center of hk and radius r has the following form for its equation: x minus h squared plus y minus k squared is equal to r squared. So this is the general equation for a circle with center hk and radius r. So in this video we're going to look to find the equation of a circle given some information, and also how to recognize when a given equation actually does represent a circle. Let's see some examples. So find the equation of the circle with center 1, negative 2 that passes through the point 4, 3. Okay, so we're given in this problem that we're talking about a circle, right? So they're telling us that we have a circle with this center. So remember that the general form for a circle is, or standard form rather, x minus h squared plus y minus k squared equals r squared. Okay, where h and k are the coordinates of the center of the circle. So here we're given that h is 1 and k is negative 2. So that's h and that's k. So this equation becomes x minus 1 squared plus, now this is y minus k, right? But k is negative. So when you take y and you subtract a negative 2, it becomes y plus 2 squared is equal to r squared. And we don't know what r is, right? We're looking for the full equation of the circle, but we have to find r as well. And we're going to find r by making use of the fact that the circle passes through this point 4, 3. Now recall that any point on the circle satisfies this equation. It's kind of like when you were looking for the equation of a line and you were given a point on the line. You could plug that point in, those coordinates in, to find other information about the line. For example, same thing applies here, right? We can plug in x equals 4 and y equals 3 because this point is on that circle, and then we can solve this equation for r. Let's do so. So x is 4, so we were looking at 4 minus 1 squared plus, and y is 3, right? So 3 plus 2 squared, that has to be equal to r squared. So we have 3 squared plus 5 squared equals r squared. So that 9 plus 25 equals r squared. So that means r squared has got to be equal to 34. So now that means r, the radius, is the square root of 34. But notice that when you write the equation of the circle, the right-hand side is always r squared. Okay, so r squared is just 34. So our full equation is this: x minus 1 squared plus y plus 2, quantity squared, is equal to 34. That's the equation of our circle, satisfying the conditions of this problem. Okay, let's try another one. Let's show that this given equation represents a circle. Okay, so we're not told this is a circle. We have to actually do some algebra to put it in a form such that it is in the standard form for a circle. And of course, just like we mentioned a moment ago, the standard form for a circle is x minus h squared plus y minus k squared equals r squared. Okay, so if we can put this equation in that form, then we know that this equation represents a circle. Okay, we're also asked to find the center of the circle and the radius. Now notice the form over here, right? Here we have a square of a binomial, and then another square of a binomial. Because we have that form, that suggests that we're going to complete the square in this equation. Now notice that these two terms contain y, right? So what we'll do is we'll take the y squared and 6y, and we'll complete the square with those two terms. And we'll add the 6, that is the constant, to the right-hand side. So this becomes x squared plus y squared plus 6y equals positive 6. And so what we can do on the left-hand side is, remember, for completing the square, the way it works is you take the coefficient attached to, in this case, y, and you divide it by 2, and then you square it. So when we take 6 and divide it by 2, we get 3. We get 3. And then we're going to take that 3, and we're going to square it, and we get 9, okay? So when you do that, when you add, in this case, 9 right here, but to do so we have to add, to maintain balance, we have to add 9 to both sides. We're going to get x squared plus y squared plus 6y plus 9 is equal to 6 plus 9, because if you add 9 to the left, you have to add 9 to the right as well. And the reason you did that is that now you're guaranteed that this is a perfect square. So it can be written in the following way: x squared plus y plus 3 squared is equal to 15. And so when you complete the square, the number that you squared, in this case the 3, that always ends up being the second term of the binomial, the binomial that ends up being squared. And notice that there was no constant, or there's no term here containing a constant times x, or no multiple of x. And if there was, I would have completed the square to get a square of a binomial involving x. So x was fine, so we could just leave it as x squared, but we changed this part by completing the square to y plus 3 squared, and the right-hand side is 15. And now we compare that with this form, right? So what would h have to be? Well, x take away what squared? Well, in this case it would be 0, right? We're really looking at x take away 0 squared plus y plus 3 squared is equal to 15. So we see that the center, right, which are the coordinates hk, the x-coordinate is 0, because that's what we're subtracting from x. Now what do we have to subtract from y to get y plus 3? That's going to be negative 3, right? Because k, this is the standard form. It's y take away something. So if it's y plus 3, we have to take away a negative 3 to get y plus 3. So the y-coordinate is negative 3. And what would the radius be? Well, the radius is the square root of the right-hand side, because the right-hand side of the equation in standard form is r squared. So r must be the square root of the right-hand side, in this case square root of 15. So this is the equation of our circle, and these are the center and the radius respectively. So notice that if you're able to put the equation into this form, or if you're able to put the equation into this form, you're looking at a circle. And so we're going to see other what are called conic sections, and we're going to put them in standard form as well. And we're going to end up with situations where, yeah, we might have a circle, but we might also have an ellipse or a hyperbola. That ability to complete the square like we did and put it in a standard form is going to be important moving forward. Okay, until next time.